In this video, we are going to be going through half of the answers in Simplifying Radical Expressions, the homework assignment. I am going to attach the answer key to this one as well. Ultimately, I am looking for your work when I grade this one, so please don't just write down these answers and assume you're going to get full credit. I will hardly give any credit if you just write the answers. I'm looking for your work. All right, so let's get to it. So on number one, the first thing I'm looking at here is, can I simplify either of these radical expressions, the square root of 15 or the square root of 20? Now the square root of 15 is 5 times 3. Neither of those are perfect squares. They're both primes. I can't break them down any farther, so I can't break down the square root of 15. The square root of 20, however, is 4 times 5, and 4 is a perfect square. So that can be broken down. So I'm just going to take down some notes in this right column here. Ultimately, you are going to have to do the even problems. But just so I can keep referring back to these, I'm just going to say notes. All right, so the square root of 20, that is the square root of 4 times 5. So you could break this down into a factor tree, 4 times 5. 4 is a perfect square, 5 is a prime, so I'd stop there. The square root of 4 is 2, and then the square root of 5 is left over because 5 is a prime. It's not a perfect square, so it's stuck inside that square root. So this becomes the square root of 15 divided by 5 times the square root of 20 is 2 root 5, so 5 times 2 root 5. What that becomes is the square root of 15 divided by 5 times 2 is 10, and then I have 10 root 5. But this is not simplified. The reason this is not simplified is because one of the properties of simplifying radical expressions says you cannot have square roots in the denominator. So what I could do is multiply by the square root of 5 over the square root of 5, and that wouldn't be wrong, but then what you're going to end up with is the square root of 15 times the square root of 5 in the numerator, and then you'd have to simplify from there. Now, there's a slightly different way that you could go about doing this problem. The way that I'm going to do this problem is look at the square root of 15. I know that 15 is 5 times 3, so the square root of 15 is the square root of 5 times the square root of 3. And I said before that it doesn't do any good to try to write it like that because you can't simplify the square root of 5 or the square root of 3, but that was before I realized we'd have a square root of 5 in the denominator. Remember, anything over itself cancels out here, so that really is just a 1. Those cancel out. The square root of 5's cancel out. So you could have gone the other approach and multiplied by the square root of 5 over itself, and then made the denominator into a 10 times 5 or a 50, and then simplified the numerator, but that's more work than we really have to do. In this one, if you realize that the square root of 15 is the square root of 5 times the square root of 3, your square root of 5's just cancel out, and your answer is the square root of 3 divided by 10. And please, when you do this, circle your answers so I can find them easily. I'm ultimately just going to be comparing them to my answer key, but if you have anything that's wrong, I want to be able to see all of your work to go through it, but I need to be able to look right where your answer is. All right, moving on, I'm doing the odd problems with you here, so let's go into number 3. Again, you have to do all of the evens and copy down my work for the odds. So number 3, this is kind of the same approach as the previous one. Can I simplify these square roots? Well, the square root of 6 is the square root of 3 times the square root of 2. Neither of those are perfect squares. 3 and 2 are not perfect squares, so I couldn't move on there. But the square root of 27 is the square root of 9 times 3. 9's a perfect square, so I could simplify that. So let's go with that approach. So the square root of 6 divided by, again over here with my notes, the square root of 27 is the square root of 9 times 3, and the square root of 9 is 3. And that square root of 3, that 3 is stuck inside of the square root because it's not a perfect square. So 3 root 3 is the square root of 27. Well, very similar to the last one. The square root of 6 is the square root of 3 times the square root of 2. My denominator is 3 root 3. Well, those 3 root 3's are going to cancel out just like the previous problem. So in this one, I get the square root of 2 divided by 3, and that is the answer. On number 5, on this one there is nothing we can simplify to start off because with the square root of 5, 5 is not a perfect square, so we have to go right into multiplying by that specific kind of one that will eliminate the square root in the denominator. Remember, that process is called rationalizing the denominator. So here we're going to multiply by the square root of 5 over itself. When we do that, the denominator, remember you multiply fractions straight across, the denominator becomes the square root of 5 times the square root of 5, which is the square root of 5 squared. The numerator becomes 4 root 5, 4 times the square root of 5. Well, when you have a square root squared, they cancel each other out, so the denominator just becomes 5, and the numerator is still 4 root 5. So 4 root 5 over 5 is the answer to this one. Make that 5 look a little bit better. I might even look a little bit worse. Let's try to fix that real quick here. I feel like Bob Ross. 4 root 5. There we go. All right. Number 7. On this one, again, we can't simplify the square root of 5 or the square root of 3, so we go right into multiplying by that special kind of 1 to rationalize the denominator. We multiply by the square root of 3 over the square root of 3. In doing that, we multiply the denominator together. We get the square root of 3 squared, which is just going to end up being a 3. In the numerator, we get the square root of 5 times the square root of 3, which is the square root of 5 times 3, or the square root of 15. And just like we discussed in number 1, the square root of 15 cannot be simplified any farther, so we are done at this step right here. All right, number 9, getting slightly more complex. Notice in the directions here it says assume all variables are greater than or equal to 0. So I don't have to worry about taking any absolute values here. This is the... if you don't understand what I just said there, don't worry about that. We're going to focus more on that in Algebra 2. But here we go. We are going to use that product property again here. So can I cancel anything out of this problem right away is really what I'm trying to do. So I've got the square root of 3, the square root of x squared, and the square root of y cubed. Down here I have another square root of y cubed and a square root of x. So there are some things I could cancel out of this problem immediately rather than going right to multiplying by that special kind of 1. And that will actually make it a little bit easier to simplify down the road. So here's what I'm thinking. I've got all these different square roots. I've got the square root of x times the square root of x, because it's the square root of x squared. I've got the square root of y cubed. So there's my numerator. The reason I wrote it that way is because look in the denominator. I have the square root of 5, but then I've got a square root of x, so one of those will be able to cancel, and I have a square root of y cubed. So the square roots of y cubed will be able to cancel each other out. So just by breaking that down right away, this becomes much more simple. We've got the square root of 3x divided by 4 root 5. So there's my first step. Just cancel out whatever I can cancel out. Now I'm going to go back to like I did in number 7 and multiply by that special kind of 1, the square root of 5 over itself. When we do that, the square root of 5 times the square root of 5, or the square root of 5 squared, becomes 5. So the denominator becomes 4 times 5, or 20. The numerator, the square root of 3 times the square root of 5 is the square root of 15, and that square root of x is stuck inside of that radical because it's not a perfect square. So that is my answer. All right, going on to number 11. On this one, I could break down the square root of 8 a little bit here. So I'm going to go ahead and do that first. I get 3 minus 3 root 3a divided by 4 times, well again, actually I'm going to erase that 4 for a second here. The square root of 8, let's just simplify that over here. So another note, the square root of 8 is the square root of 4 times 2. You could really do this in your head, but the square root of 4 is 2, and that root 2 is left over. 2 root 2 is the square root of 8. So this denominator becomes 4 times 2 root 2, and a is stuck inside that square root there because it's not a perfect square. So our denominator becomes 3 minus 3 root 3a. Our denominator becomes 8 root 2a. Now in order to get this out of the denominator, I do have to multiply by that special kind of 1 again, so the square root of 2a over itself, ultimately creating the square root of 2a quantity squared, so the square root will cancel out with a square. In the numerator, I'm going to have to distribute this square root of 2a onto both of these terms in this binomial. So in the numerator, it becomes 3 square root 2a minus 3, and then I have a square root times a square root, so that product property tells me I can multiply the radicands together, so I get the square root of 3 times 2 is 6, 8 times a is a squared. Denominator becomes 8 times the square root squared is going to cancel, so 8 times 2a, or 16a. Now in this one we have a square root of a squared. The square root and square will cancel out there, so just the 6 will be stuck underneath the radical. So I'm going to have to take this over to the right now. So I have 3 square root 2a minus 3, again, the square root and square cancel, so minus 3a. The square root of 6 is stuck, because 6 is not a perfect square and doesn't have any perfect squares hiding in it, and the denominator of 16a. And that is the answer for that one. Moving on to the next page, number 13. All right, so on this one, right away, I see I have a square root of a square, so I'm going to cancel out the square root and square. So this is going to become 4x cubed minus 3 root 3x over 3, again, the square root and square cancel, so 3x. The square root of 3 is stuck because 3 is not a perfect square. And now I'm going to multiply by that special kind of 1 to cancel out that radical in the denominator, so to rationalize the denominator. So I need to multiply by the square root of 3 over itself. When I distribute in the numerator, I end up with 4x cubed square root 3 minus, here I've got a square root of 3 times the square root of 3, so the square root of 3 squared. The square root of 3 squared, so again, just another note here. The square root of 3 squared, the square root and square cancel out, so it equals just 3. So right here, this is going to equal 3 root x. So I have a 3 out in front. I'll just show another step. I have the 3 out in front. The root 3 times the root 3 is another 3. And then I have the root x left over. In the denominator, I have 3 times x, and then again another square root of 3 squared, which again equals 3. So multiplying these two together, I get a 3. I also have this 3 out here, so I'll again write another step. It's 3x times root 3 is 3. So what this becomes then is 4x cubed root 3 minus 9 root x divided by 3 times 3 is 9x. And that is it. Going on to the next one, this is the first one on this worksheet that I'm going to be doing that has addition or subtraction in the denominator, and actually the remaining 4 problems on this worksheet that I'm going to be going through have addition or subtraction. So that is where you have to multiply by the conjugate of this 4 plus 4 root 5. So since this has addition, the conjugate is going to have subtraction. And again, we do this, we multiply by 4 minus 4 root 5 to create the difference of two squares pattern in the denominator, where we have a plus b times a minus b, which ultimately will FOIL out into a squared minus b squared, canceling out any of those square roots that we might have. But we can't just multiply by this value, we have to multiply by a special kind of 1, so we put the same thing over itself, which always equals 1. So we're just multiplying this expression by a big old 1. So we need to distribute in the numerator, FOIL in the denominator, first outside, inside, last. And let's see what we end up with. We have 3 times 4 is 12 minus 3 times 4 root 5 is 12 root 5. The denominator, the first 2 multiply to 16. The outside 2 will cancel with the inside 2, because you get negative 16 root 5, positive 16 root 5, those will cancel. And then the last 2, a negative times a positive is a negative. 4 root 5 times 4 root 5 is 16 root 5 squared. On this first one, I'll show my work. 16 times root 5 squared. On the future ones, I'll just say 16 times root 5 squared is 16 times 5, and then I'll give the result of that. But on this one, I can show that extra step. So I have 12 minus 12 root 5 divided by 16 minus 16 times 5. So 16 times 5 is 80. 16 minus 80 is negative 64. But we're not done with this one yet, because I know that 12 here is at least divisible by 2, so 12 64ths can be simplified. So this one is not done just yet. So let's see if I take 12 64ths, 0.1875. So that's 3 16ths is 0.1875. 3 16ths, yep, 0.1875. So this is 3 16ths. That's a negative. Now when you simplify a fraction, the negative should always go into the numerator. So this positive divided by a negative is a negative divided by a negative is a positive, and again we have 12/64, which is going to be 3/16, so this becomes a 3, and we still have our root 5. All right, so there we go. Again, you could factor out the 12, and you end up with 1 minus root 5 over negative 64, and then the 12/64 would become a negative 3/16, and you have 1 minus root 5. Now, there was actually a discussion between the math department, and we said that this is actually just as simplified as this one. So if you want to distribute it in this negative 3, or if you want to leave it as this, either one of these is acceptable. So either way, that's okay. If you look at the answer key, number 15, they've got it, the first way that I had it, negative 3 plus 3 root 5 over 16. So negative 3 plus 3 root 5 over 16, that's going to be this first one here. All right, so let me get rid of this real quick here. And let's go into the next one. Let's go on to number 17. So again, we've got subtraction in the denominator. So I'm going to multiply by the conjugate, which will use addition. So I'm going to multiply by negative 3 plus 3 root 3 over itself, negative 3 plus 3 root 3, ultimately creating the difference of two squares pattern in the denominator. When I distribute in the numerator here, I'm going to get a negative 15 plus 15 root 3 divided by, I need to FOIL in the denominator, first outside, inside, last. So negative 3 times negative 3 is a positive 9. The outside and inside will cancel, and the last two will give me a negative 3 times 3 is 9. Root 3 times root 3 is 3. So this is 9 times 3, or 27. So this one becomes negative 15 plus 15 root 3 over 9 minus 27 is negative 18. All right, so 15 and 18 are divisible by 3. So on this one, 15 18ths, if I divide a 3 out of 15, I get a 5. 3 out of 18 is a 6. So 15 18ths is 5 6. So this is going to end up being a negative divided by negative is a positive, 5 over 6, plus, oh, actually a positive divided by negative is a negative, so minus 15 18ths, again 5 over 6, and then my root 3. So each one of these terms is getting divided by that negative 18. So negative divided by negative is a positive, positive divided by negative is a negative, otherwise my root 3 stays in the problem there. All right, so let me just compare that, number 17 right here. Let's make sure they're giving you the same format, 5 minus 5 root 3 over 6, 5 minus 5 root 3 over 6, yep. All right, and the last, oh, nope, just kidding, 2 more to go with you. This one, again, we've got addition or subtraction in the denominator, so I need to multiply by the conjugate of the denominator. So this one is going to be negative 4 minus 4 root 2. Since this originally had an addition, we're going to use subtraction for the conjugate. And we need to have the same thing over itself to create that special kind of 1. All right, so we are going to have to FOIL in the numerator and the denominator on this one because we have a binomial in the numerator as well. So we have first, outside, inside, last. And again, first, outside, inside, and last. So when we multiply the numerators together, we get 2 times negative 4 is negative 8. The outside 2, negative 4 root 2 times 2 is negative 8 root 2. The inside is positive 5 root 3 times negative 4, or negative 20 root 3. And the last 2 is a negative times a positive, so a negative 20 root 6. There is my numerator. The denominator, we have the difference of two squares pattern. So the first 2 multiplied together gives me a positive 16. The outside 2 and the inside 2 will cancel, and the last 2 will give me a negative. 4 root 2 times 4 root 2 is 16 root 2 squared, so 16 times 2 is 32. All right, so this becomes, let's see, any like terms in the numerator there? Nope. So I leave my numerator alone. Negative 8 minus 8 root 2 minus 20 root 3 minus 20 root 6. So no common radicals there. And then 16 minus 32 is negative 16. But look at all of your coefficients here. They all have numbers that are even. So including 16 in your denominator here. So we can simplify. 8/16 is 1/2. And here's another 8/16. 20/16. Those are both divisible by 2. You'd get 10/8, which is divisible by 2. You get 5/4. And then again another 5/4 here. So all of these are going to be able to be simplified a little bit. All right, so let's see. Negative over a negative is a positive. 8/16 is 1/2, so I have a 1 over 2. Here 8/16 is going to be a positive 1 over 2, so I just have root 2. I don't have to write the 1 in front of it. 20/16, the negatives will cancel and give me a positive. If I divide this by 2, I get 10/8. Oh, I apologize. I need to have fourths. I said 20/16 is 5/4, so this, I need to get rid of this real quick here. My denominator is not a 2, it's a 4. Let's see. Let me show you this one. Kind of show you the behind the scenes of this one. So what I'm doing is factoring out the greatest common factor. The greatest common factor between 8 and 20 is going to be a 4. Since these are negative, I'm going to factor out a negative 4. And what remains when I factor out a negative 4 is 2 plus 2 root 2 plus 5 root 3 plus 5 root 6 divided by negative 16 is negative 4 times 4. These negative 4s are canceling. So ultimately that's what's going on here. And I think that's a little bit more straightforward if I do it that way. All right, so I end up with 2 plus 2 root 2 plus 5 root 3 plus 5 root 6 all over 4. All over 4. So kind of a nasty looking answer, but that satisfies those 3 properties of simplifying radical expressions. Let me just make sure that the authors of this sheet put it in the same order. 2 plus 2 root 2 plus 5 root 3 plus 5 root 6 over 2. Yep, over 4. That is the same. All right. And the last one, number 21, multiply by the conjugate. So on this one, we multiply by 4 plus root 5 over itself. 4 plus root 5. Okay. And then we need to FOIL the numerator and denominator because we have binomials in both of them again. So we end up with 4 times root 5 is 4 root 5. The outside, first outside, inside last. The outside 2 gives me a root 5 times root 5, or just 5. The inside 2 gives me 3 times 4, or 12. And the last 2 gives me 3 root 5. In the denominator, that's the difference of 2 squares pattern. So the first 2 gives me a 16. The outside and inside will cancel each other out. And the last 2, a negative times a positive is negative. Root 5 times root 5 is root 5 squared, or 5. Simplifying this a little bit here, we have some like terms. The 4 root 5 and 3 root 5 combine to 7 root 5. The 5 and 12 combine to a 17. So my numerator is 7 root 5 plus 17. And the denominator, 16 minus 5, is 11. And 7 is not divisible by 11. And there's nothing to simplify there. So that is the answer, 7 root 5 plus 17 over 11, just as the answer key shows there. All right, so you are responsible for the even problems, but you should also copy down my work if you have not done so already for the odd problems and use those as a reference. So a lot of these are very similar to the ones that they are next to. Number 14 looks probably like the most complex one. 12's similarly complex, but they are very similar to the questions that are right next to them. So please use these to your advantage when you're trying to do the even problems. All right, thank you.